Hi, welcome to this demonstration of analyzing Visual Builder applications with Oracle Application Performance Monitoring. My name is Shai Schmelzer. In this demonstration, we're going to show you how to track and analyze your Visual Builder applications using Oracle APM. The Oracle Application Performance Monitoring tool provides you with a dashboard, Trace Explorer to trace activities in your application, the ability to define custom attributes that you're tracking, executing multiple queries to get reports on the activity in your application, and it's very easy to integrate it into a Visual Builder application. Let's see how. In Oracle Cloud, there's a section for application performance monitoring. We're going to go to our home page. Over here, we can choose the compartment we're working on, the domain that we're working on, and then see statistics about the applications and alarms that we currently have. We're going to focus on monitoring our web application and specifically this APM test application. Clicking on it takes us into a page where we can get detailed information about what happened in our application and what users have been doing. Right now it's set for the last 24 hours. I'm going to change the time scale to look at the last 30 minutes of activity in our application. We can see that in the last 30 minutes, we had most of the customers using macOS to access our application and from a personal computer. They were using a combination of Firefox and Chrome to access the application. Most of them had great satisfaction with our application, and some of them had a tolerating issue, probably because of performance or errors that were thrown their way. Over here, we can see the overall performance of our AJAX calls, the number of those, and the number of AJAX calls that resulted in errors. And over here, we can see a chart of our response times, both in terms of page response times and AJAX response times. We can see it's pretty consistent across the board. Let me show you a little bit of interaction with the application that we're tracking here. I'm going to use this Firefox browser, and I'm going to show you that in this application, we see a list of employees. We can scroll down to fetch more employees. This invokes a REST call. Then we can choose an employee, go and edit the data about this employee, fetch a list of laptops, fetch another list of department, and fetch a list of countries, and save the data. So we did some interaction with this page and with another page. And then we can also show you this button that actually is going to result in an error message. So when we click on this, we're calling REST service twice, and each one of those calls results in an error. Then there are other pages that we can interact with in our application, but we're not going to drill into those right now. They allow you, for example, to look up models of laptops. Let's go back into our APM and see an update of this data, but this time we're going to switch over to look at our Trace Explorer. The Trace Explorer shows us all the interactions that are happening in our application. Right now it's showing us the last 100 interactions that happened in our application. We can see for each interaction what type of interaction was this. For example, we had some full page updates and some partial page updates over here. We can see the duration that it took, and we can also see that some of those interactions involved multiple things happening behind the scene. For example, let's drill into this operation over here. Okay, we can see that we did a full page update for this page, and that this involves invoking two AJAX calls. If we drill down on each one of those, we can see exactly what we invoked here. For example, over here, we did a patch operation to update one of our employees, employee 18. After we did this update, we did another operation over here, and this was a GET request to get information about our employees, and this showed us a list of employees with those fields. Those two happened one after the other, and as a result, we got our page in about a second and a third. In our tracing, we can also inject additional fields into the report. For example, we can look up the username of the users that ran the page. Okay. This way we know that I ran the pages and I know that I ran into errors, for example, or things like that. I can get this information from here. There's a lot of information that you can retrieve from here. For example, if we wanted to know a just operation that ended up as an error, we can add a condition to our fetch. This shows us the errors that happened when we call the REST service. Again, we can click on it and see the REST service that ended up causing us the error over here. Okay. For example, see the exact parameters that cause us to raise an error. So this would help us basically find out which customers are running into errors, help them fix the error by fixing the application or fixing their behavior. Let's remove this where condition over here and see the rest of the information. One of the nice things about the attributes here is that I can also inject my own custom attributes. So one of those custom attributes, I use that one to indicate which page we're actually accessing. And now we also know which page in our application each one of those interactions happened with. So for example, we can look over here and see that when we went to the employee edit page, we did a full update of the page. And if we again drill down into it, we can see that we needed to call over here this operation to get the information about employee number 18, which is the employee we then ended up updating. One of the nice things about the Trace Explorer is that we can also create our own custom queries to get us all sorts of information. Let me show you some samples of queries. If I use a group by APM RAM type, I can see the types of interactions that happened in the last 60 minutes or again in any time frame. I can see how many AJAX calls we performed, what was the maximum time an AJAX call took, and what is the average time of our AJAX calls. I can see also page loads and page updates and what's the average time for each one of those. Make sure that our pages load or update quickly enough. This query shows us access to our REST services in the backend. Let's resize this a little bit. Okay. And we can see, for example, that to get the data about department, we call this one 9 times in the last 60 minutes. We call the get data about employees 19 times. And again, we can see the average time that it took us to invoke each one of those REST services. If we can see that we have REST services that are taking longer, like the location, we might want to go in and examine what exactly can we do to make this REST call faster. This query combines our custom attributes to show us which pages were accessed by how many users. So how many distinct users have been interacting with our pages. And then I can also click to see who are the users that were actually accessing each one of those pages. Let's look at what is involved in hooking Visual Builder application to work with APM. The process is actually very simple. This is our application, and the first thing that we need to do is update the index.html page of our application. All we needed to do is add this script section. This script section provides parameters to APM, giving a name to the application so we can track the application by name, and of course indicating which server and how to securely load data into it. We also needed to have this line of code that basically brings in the APM JavaScript library into our index page. Therefore, it's available in each one of the pages in our application. Next, if we actually looked at the event listeners that we have in our application, what we did here is we used the VB enter event and we added one action chain here at the top, would be the first one, to call a function, okay, and passing in a parameter that is mapped to the username that is logged in. This is the username that is logged in. Now let's look at the function itself. Function itself basically gets the argument and then sets the value for the username attribute in APM. This is how our application in the APM knows which user is actually accessing each one of the pages. We did one more thing at the page level. In each one of our pages in the JavaScript section, we updated our page module to have a function like this that sets the parameter called attribute2 to the name of the page. So in the employee edit page, it would be this entry. If we look at the laptop page, it would be this entry. Those together allowed us to get this information into APM to better understand the information that it provides. So hopefully this has shown you how deep is the information that you can gather from Oracle Application Performance Monitoring and how it can help you tune your application, as well as how easy it is to hook up Visual Builder to use APM.